Okay, so we are now recording, and eventually I'm going to share my screen to show you guys an idea. But I wanted to lay out for you, for everybody, what the plan is for the next. Really, only after today, we only have 4 assignments, four more days of e-learning, and so we're. I mean, if you think of it like that, you're really down to less than a week of school. 4 days. Next Monday, next Thursday, then the following Monday and Thursday. But we're going to finish off 18, and then we won't do another pivot quiz. We're just going to do kind of a bigger worksheet that kind of encompasses all of them. All right, and so that'll be our kind of our 18 review. I'm not sure. We might do one section of 19, which is lateral surface area, but we'll see how next week goes. We'll see. I'm trying to, we're not getting into a deep dive in all this. This is a little bit, I think can be more complicated stuff with the volume formulas and everything like that. So we're kind of keeping it on the surface a little bit, and we'll do the same today and tomorrow and next Monday. So, okay, so that's kind of the plan. We're going to finish up 18. Today we're going to talk about prisms and cylinders, which was the assignment on Monday. But I want to kind of give you my spin on it, and then the assignment, as you saw today, kind of goes into the next section for today's prisms and cylinders, and goes into cones coming up. So, all right, so let's get rolling here. Let me connect this and share my screen. Okay. All right, can everybody see that? All right. If not, make sure you let me know, either in the chat program or shake your head or let me know. All right, so this is what we're going to talk about today. But before we get to that, I've got another thing I want to show you. Since we'll be talking about cones, we're going to do an application of cones in an ice cream setting. Now, last year I was able to bring the ice cream into the classroom, of course. Well, things are a little different this year. So here's the plan. Let me make sure that's not glare so you can see that. All right, there we go. Can you read that? All right, so what we're going to do is by class period have a setup for a drive-through. If you look, this is where we live, Mechanicsburg Road. There's our home. And then there's a space over here where my finger is, which is a trail that we'll set up a tent, and it's kind of like a drive-through right here. We'll have it set up that you can drive through. If you can't drive because you don't have your license, well then of course your parents. And if for some reason like you're not able to come when the time slot's available, then we'll have a time at the end where everybody can try and come as well. So, but right now we have it for next Wednesday, but that is my daughter's birthday, so we might have to change it. I just used that date because looking at the weather, it looked like the best weather. So, but right now this is the tentative schedule. 1 to 2 for first period, 2 to 3 for second, 3 to 4 for third, 4 to 5 for sixth, and 5 to 6 for seventh period. And then I'm also going to invite, and you can spread the word on this, anybody that I've had former geometry students can come between 6 and 7. And that would also be available. So let's say that you don't have a ride, or a parent that if you're in first period or second period during the day, then you can come during that 6 to 7 time slot in the evening. So anyways, that's the idea. We'll just be serving in a cone. That's the only choice. You only get a cone because we're talking about cones. Well, in a cone, either vanilla or chocolate ice cream. Again, that right now, tentatively, it's next Wednesday, but we may change that. That may get changed. All right. Questions on that? Good idea? Yeah? Yay? Nay? Yeah? Hunter, you like that idea?
Yes, I do.
You only can get one drive-through, Hunter. You can't come through twice.
Oh, come on. Why not?
Josie, do you like ice cream?
Yeah.
So you like this idea then? You'll be able to stop by and drive through, grab some an ice cream cone?
Yeah.
Noni, how about you? Is she still with us? She might not be with us anymore. Oh no, she's still there. You can use the chat, Noni. Yeah, what do you say up there? Noni is lactose intolerant. All right. Well, you can come just get the cone. No ice cream. And Sophie, how about you? You like that idea?
Yeah, I don't really eat ice cream though.
You can come just get the cone too then.
Okay.
This is the application. So we're not finding the volume of cone. It's just for fun. I mean, we'll eventually do the volume of a cone, but not during this little thing. Okay, so that's the idea. That's right now, tentatively next Wednesday. We're going to see. We might change that Monday or Tuesday, just dependent upon the weather. Okay, so that's that. All right, let's go to this. 18.1, volume of prisms and cylinders. All right, what is this? What does this look like? Well, I'm gonna put this on here. Here's the top of a cone or a cylinder. These are dog treats. We have them in a jar for the dogs. But there's an example of a cylinder. And this happens to be what we would call a right cylinder because it stands straight up. It's not tilted like the Leaning Tower of Pisa. It stands straight up. So if it's not standing straight up, if it's tilted, then it's called oblique. O-B-L-I-Q-U-E, oblique. And in this case, this is a right cylinder. Okay. Here's an example of a prism. You can see that it's just basically like a box. We could set that down and have thickness to it, and we can find the volume that the box creates. Okay, so just some physical pieces. I'm sure you guys have some in your rooms, right where you're at right now, that would either be like a box or a cube or a cylinder. So let me talk about these a little bit more detailed. All right, what is a prism? I just told you it's kind of like a box. Some people call, if all sides are congruent, then it's called a cube. Are congruent, not pi, are congruent, then it's called a cube. It doesn't look very good. Okay, we already talked about right or oblique, non-right. All right, so the volume formula for a prism is volume is equal to, now that's a capital B. That's a capital letter. And there's a reason. That signifies that it represents another formula. So it's almost like a formula inside of a formula, the area of the base. And so capital B equals the area of the base. Now that's important because the base of the figure can change. In a prism, let me draw one real quick. Now, how many of you just doodling can draw a box? But I kind of like it. Use the dotted lines to show the parts that are hidden. So there's a box, and so I'm going to shade in the base of the box, which would be the bottom part. Okay, so there's the base of the box. And so the area of the base, in this case, it's a square or a rectangle, and that is length times width. And then the height of the box, this one's considered a right, and so we're just going to put an H here, and that represents the height of the box. And so the length times width over here is just the area of the base, and then this is the height of the box. Okay, so that volume then is that formula. It can be also used when we're talking about a cylinder. Okay, so a cylinder is, maybe it looks something like this. Okay, so there's a cylinder. All right, so then the base, now we actually have two bases. You can think of it like that. This could be considered a base, or this could be considered a base. Since it's the same type of figure, it's not a cone, but since it's the same type of figure, then we could call this our base. That could be our base, or just like the prism, the base could be down here. All right, so now the volume for a cylinder is the exact same, the area of the base times the height. The area of the base times the height. And so capital B is still area of the base, but in this case, since it's a circle, then we find the area differently. It is not length times width like it is in a prism, it is pi r squared. And so the volume formula would be pi r squared times the height. And so if you keep that in mind, then the formula is pretty simple to remember. It's just the only thing that changes is how do you find the area of the base? And so that's all you have to do. What if that base changes to a trapezoid? Or what if that base changes to a rectangle, like in this type of scenario? So let's say this was our base. More than likely, in a real life situation, the base could be anything. It could be a star. It could be a triangle, and so, I mean, it could be a triangular prism. So let me make a few more pictures so you get the idea of what some other prisms or cylinders would look like. And then we're also going to talk about what do we do if it's oblique. Okay. Any questions on this sheet before I toss it aside? We good? Speak up now. Okay. All right, so what if we have a triangular prism? Well, all that means, a triangular prism, is that the base is a triangle. So let's start off with, I don't know, just a normal triangle here. And then we draw the height. Try and make the triangle the same. Okay, maybe that's that's a thick piece of cheesecake, which my daughter made last night, right? Or cheese, a block of cheese. So in this case, when we have this, the volume is still the area of the base times the height. We just have to apply it now so that our base has two bases. There's two bases. So our base could either be this top triangle here or this one down here. Does it really matter? No, it doesn't, because they're the same. They're the exact same. And so we would take the area of the base would be 1/2 base times height times the height. So now that gets you got to be careful on that, because this base and height is dealing with this triangle. And so sometimes on these problems, you might see this again. It might be helpful to pull this triangle out and look at it separately. So if that happens to be a right triangle, that would make this real easy, because this would be our base and this would be our height. If it were not a right triangle, then we'd have to find the area using the other methods that we know. The cosine law helps us find all the parts that we can find the height. Pythagorean theorem, if it's a right triangle. Well, it just depends on what they throw at us, but we'd have to find the area of the triangle. And then once we know the area of the triangle, then we multiply that by this h right here, which is the height of the prism. Okay, so this is the height of the triangle, and this is the height of the prism. That would be over here. Now, since it's a right triangular prism, then this height and this height are all the same. Okay. All right, let's take a look at a picture that might be, I don't know, an oblique cylinder. What would that look like? All right, an oblique cylinder would look something like this. I didn't do that great, but you get the idea. So here's our base, or this could be our base, it doesn't matter. Those are the same, two bases, which are equal. Okay, two equal bases. And then in a case like this, they have to give you a little bit more information. And so what you do is there's actually a law or a rule that would tell you that this is true, which isn't important other than just knowing that that's our height. And so it's like the perpendicular distance that we had talked about before is the shortest distance between 2 points. And you don't want to go at an angle, because this is longer from here to here. As you can see, that's like the hypotenuse of a right triangle. So the height would still be this. And so then in a case like this, it would still be the area of the base times the height. And the area of the base is a circle, so pi r squared times height. And they're going to give you that information. In fact, on today's assignment, I'm pretty sure that there's a problem just like that, where they give you this height and you have to find the volume of the figure. Okay? So this would be what we would call an oblique cylinder. And what we're doing up there is a right triangular prism. All right, any questions? If so, speak up. Otherwise, I'm gonna move on. Okay. Some of the problems that are common in this section are what are called composite figures. Now, that's not a new term for us. When we were doing area of different figures, we had a whole section on composite figures, and we did it on the graph board, and we found the area of this section and this section and this section, and then that gave us the entire area. So let me create a picture of composite figures. Let's say that we have a short but wide cylinder like that. So there's a short and wide cylinder. And on top of the short and wide cylinder, we have a prism. So that would look like this. There we go. So now we've got, if all this were one piece. So now I use different color ink here so you can see, that this is where it intersects the top of the cylinder. But you would think of this as one unit. So you've got the cylinder and you've got the prism. And so to find the volume, you're going to take the volume of the cylinder. You're going to add to it the volume of the prism. So now nothing really changes in what we were just doing, except it just becomes a little bit of a bigger problem. The cylinder is pi r squared times the height, and the prism is length times the width times the height. Now, this height is the height of the cylinder, and then this height is the height of the prism. Okay, so now that's a fairly large I don't like that glare. Sorry about that, but there we go. That's a little bit better. So we have a cylinder plus a prism, and that gives you, it's a fairly long formula, but that's how you find the volume of a composite figure. Okay. All right, so let's do this. Let's change out now and look at a problem. All right, now this is from Mondays. So this was volume of prisms and cylinders on Monday. Let's take a look at number 5. All right, so there's the picture. And we have the area of the base. That's what the capital B represents. The area of the base is 9. And then the height is 3. Okay. So let me redraw that real quick. Okay, so are you guys with me still? Okay, good. All right, so there's a picture, and we've got the base is 9 and the height is 3. And so the volume is literally the area of the base times the height. And so the volume is 27 feet. Now, cubed. Now, that's something we haven't talked about. Because area is feet squared, pi r squared, and units squared. And then we're adding another unit to it, and we're multiplying. So we end up with volume is always in the cube measurement. And so this would be 27 feet cubed. All right. Any questions on that? Number 5. Speak up now. All right. Keep moving along. Okay, so from today's, let's take a look and see if I can find this. Nope, that's today's. Hold on here. All right, so now on this one we have a pyramid. All right, now this is an interesting diagram. All right, so let's come here first. So if I'm gonna look at a pyramid, basically a pyramid can have any kind of base, except it comes to a point. So let's say that we just have a regular rectangular pyramid as the base. I mean, that's in simplest form, that's all a pyramid is. You got a base of any kind of figure. Let's say that the pyramid is a triangle. There's a pyramid with a triangle as a base. It could be a square. So the square would look like this. Say it's here. Okay. Actually, on this one, this wouldn't even need to be dotted. That can be square. Okay, so when we're talking pyramids, there's just a little adjustment we have to make because we only have one base. We don't have two bases. And so the normal volume was the area of the base times height. But since now we're only have one base, we don't have the full, I mean, like if this were a prism, this would be to go up. You see that just doesn't make sense. It's missing a part of it. You see, in fact, if we were at school, let me stop sharing. See if I can get you to visualize this. If we were at school, I have a prism, and then I can fit like a box prism, and I can fit a pyramid on the inside of it, and you can kind of see how they're shaped, and it just fits right inside. And it actually, we'd take water and we can pour it in, and it actually equals 1/3, meaning the pyramid volume is 1/3 the volume of the prism. Okay, so let me go back to share screen and we'll look at that formula. Okay, so as you can see, if you have to follow my mouse now because I'm going to outline it, the volume of a pyramid can be found by first calculating the area of the base, then use the formula 1/3 base times height. So it's very, very similar to the cylinder and of course the prism. And so now let's go back to the paper. And so the volume, since there's only one base, is 1/3 the area of the base times the height. So everything else is the same, except now we take 1/3 of it. Okay. All right, let's take a look at one of these problems from today. Let's take a look at number 3. Number 3 says, that we have a pyramid, as you can see, and it looks like it's a square. And so we have 5 times 5. So we have 5 times 5. It's very similar to this picture. This is the area of the base. So it's 25. And then we have a height of 5. So that's also the same height. Okay, so h equals 5. And so the volume would be 1/3 area of the base times height, 1/3. 5 times 5 is 25. And then the height is also 5. So 25 times 5. And so now we have 1/3 of 125. That's not an even number. And so we end up with, what is that, 41.6. Is that feet squared? Let's see what they have. Oh, meters. Meters squared times the height, which would make it meters cubed. Let's see, did they tell us to round it to the nearest hundredth or anything? Let me see what the directions say. Calculate the following volume, the volume of the following prisms. I don't see them rounding it to the nearest. Okay. Yeah, it doesn't matter, Hunter. I would just try and follow the, whatever the example says. If it says round to the nearest 10th, great. Like on this one, they didn't even have to round. So, yeah, but it just depends, whatever. All right, let's take a look down here now. Okay, let's take a look at number 6. This will be the last one that we'll do for the day. Okay. All right, so as you can see, we've got 2 triangular or pyramids, really, on each side, and then we've got a prism on the inside. Okay, so here's, this is kind of a long way to look at it, but this is how I like to look at it. Okay, volume of pyramid plus prism plus pyramid. Okay, because there's 3 parts. It's a composite figure. There's 3 parts. 1, 2, and 3. Now, do these 2 pyramids happen to be the same? Let's go back to the picture and look. Because if they do, 10, 10, 8, yeah, they kind of look the same to me. 1, right? They kind of look the same. And so then we can simplify our volume formula and say, all right, 2 times the area or the volume of the pyramid plus the volume of the prism. Okay, and so that's these 2 together. All right, so now let's find the volume of the pyramid first. All right, so the pyramid. Am I spelling that right? I don't even look right. Well, that's not right either. Pyramid, Pyramid. All right, well, I don't know why my eyes are playing tricks on me. That didn't seem right. Okay, so volume of a pyramid we know is 1/3 the area of the base times the height. Okay, 1/3 the area of the base times the height. All right, so in this case, we're going to take 1/3. The area of the base looks like that is 8 times 1. Eight times 1, because that is the length. I'm going to follow it with the mouse. 8, and then it looks like it has a 1. 8 times 1. And then the height of it is 10. Notice that it went right in the middle, because you got to go from the point and you got to go down. Okay, so let's do the math there. 8 times 1 is 8, times 10 is 80, divided by 3. Again, that doesn't turn out equally. And so I would leave it like that. Let's not reduce it yet. Let's just put it into the formula, and we'll reduce it here in a little bit. So 80 over 3. Now let's find the volume of the prism. You get another sheet of paper. The prism is just that little block that's in between, the two pyramids. Okay, so that little block is a prism, volume of prism. Is the area of the base times the height. So in this case, the area of the base, that looks like, what, 1 times 1? That's what I would say. 1 times 1, 1 meter times 1 meter, and then the height would be 8. So that's pretty simple. That would make this 1 times 1 times 8 is 8 meters cubed. Okay, so now what we're going to do is, let me use a different color marker. So we substituted the volume of the pyramid into the formula there. And now we're going to take the volume of the prism and put it there. All right, so composite figure, here we go. Volume is equal to 2 times the volume of the pyramid plus the volume of the prism. All right, let's continue on. All right, 2 times 80 is 160 over 3 plus 8. You could simplify these first over here and then add, doesn't really matter. Your order in this case, that would be, let's see, 50 would be 150, so 53 and 1/3 plus 8. And so we end up with 61 and 1/3, or 61.3 repeating. Is that in meters? Let's take a look. Yep, meters it is. Meters cubed. Did they tell us to go back, read the directions? They tell us to round it to anything. Answer the questions and find the missing values. No, it doesn't tell us. But that is our final answer, 61.3. And let's see, how did we do on that? Yep, that's it. Okay. Yeah, you can put 61.4. It just depends on what they would, Noni, it just depends what they would tell you to round it to. So, all right. Questions? Anybody have any questions? We basically covered 2 sections, finding the volume of prisms and cylinders, and then we just talked about finding the volume of pyramids, and then composite functions. Are we good? No questions? All right. Then we're done. We'll do this, we'll probably do it again next Monday, because we're going to do the cones formula on Monday, and then we'll put more onto the decision on when we're going to do The ice cream delivery. Sophie, would you prefer like a an ice cream sandwich rather than a cone? Or you just don't like?
No,
No.
I just don't like ice cream that much.
Noni, I don't want to make you sick. So would you prefer a cookie? Come on now, you got to participate as part of the fun. You got to drive by, and I'm gonna be wearing an apron, have a mask on. Hunter, you can take a picture of me and make fun of me. Okay, yeah. You might have to show up and go through the line with them though. See, that's the problem. Like, hey, I'll take that car in front of me. I'll take their ice cream or the one behind me if they don't want it. So, all righty. No other questions. I'll let you go, and I'll get this posted as soon as it converts over. And if you have any questions, make sure you email me. All right. Take care, guys. Bye, everybody.